told by those who claim to know these things that long, long ago in a land that time forgot, it was a time where monsters roamed the planet, where great creatures ruled the world. No one knows what actually happened in this distant past, although the prevailing claim is that 65 million years ago, a great catastrophe befell the planet. And these great creatures were wiped out, buried in mud and ice, immortalised in time, awaiting discovery. When the first of these creatures' remains were discovered, in 1841 Sir Richard Owen would give these ancient creatures their name, Dinosaur, meaning terrible lizard, and brought into the public eye in the early 1800s by a young woman named Mary Anning, who would go on to discover the world's first ichthyosaur in 1821. As more of these creatures were unearthed, so the public became mesmerised by them, and filmmakers wove fantastic stories, suggesting these prehistoric creatures could be grown from DNA taken from the blood of a prehistoric mosquito trapped in amber, bringing these terrible beasts back to life with books such as Michael Crichton's Jurassic Park.
Ever since I was a child, I just fell in love with this stuff. I mean, how cool would it be to have a real dinosaur park? But is finding dino DNA really all that far-fetched? Is there another means of obtaining it? Well, what if I was to tell you that there have been some recent finds regarding dinosaurs that has caused quite a stir within the dinosaur community, something that has been kept very quiet since first discovered in the early 90s. In fact, the discovery was so unsettling that it was hidden away because, well, first of all, it was considered impossible and therefore simply a bad mistake. And then secondly, because if found to be true, then this new discovery would have significant bearing on beliefs that we have about the distant past.
When it comes to researching dinosaurs, the professional involved was called a paleontologist, but in recent years has involved other disciplines, such as biological sciences, giving them the more recent title of paleobiologist. As technology and scientific methodologies have advanced, the dinosaur or fossil hunter has many new tools at his disposal when trying to understand the prehistoric past. Joseph Hubbard, often referred to as Indiana Joe by his colleagues, is one of the new breed of fossil hunters who travel internationally looking for the latest evidences being uncovered, bringing fresh understanding to these ancient creatures.
So, let's have a look at what's in my little bag here. This is an Edmontosaurus dinosaur bone, a fossil one. For those who don't know, Edmontosaurus was a big dinosaur. He was a herbivore, he ate plants, and these particular bones came from Texas in the USA. Now, why am I here talking to you about what quite frankly looks like a dull old rock? Well, I have another fossil in here, and it's a little more spectacular perhaps, or at least unusual. Have a look at this. This is a fossilised teddy bear, technically permineralised, but we'll talk more about that later. So what has this fossil teddy bear and this giant prehistoric dinosaur bone have in common? And what have either of them got to do with Jurassic Park? Well, patience, we'll come on to that later. We're also going to be talking to some friends of mine. We're going to be looking at some compelling research, some amazing experiments, and they will reveal some rather unnerving information. But before we do all of that, let's go to the seaside. By the way, if these discoveries really are what they seem to indicate, then we will need to rewrite history, and it's going to have a shocking outcome, including for who we are as human beings. So here we are, we've just arrived on the windy east coast of Scotland. Not particularly well known for its giant dinosaur finds, but all up and down this part of the coast you can find some spectacular fossil plants, as well as giant fossil tree stumps. And we need to show you some examples of these, as well as talk about what actually is a fossil, because it will relate directly to what we're going to be showing you later on in the programme. I actually just spotted a fossil just walking along here, so come down with me. Let me show you what I found. Somewhere, here it is. This is a great example of the kind of fossil you find down here. Let's just clean it up a little bit. It's a fossil lepidodendron. Lepidodendron? It was a giant tree. And what we're seeing here are the remains, the imprint of the bark. You see, that's really what a fossil is. It's from the Latin. Fos means a hole, and il refers to what's in it. And so we've got the preserved remains of a giant, once living tree that's now dead. Great stuff that you can find all up and down this beach, so let's go find some more. But to really get to grips to all the different types of fossils that there are, we need to have a look at some examples from around the world, some of which are probably a little bit more familiar to you. So come with me as we go and have a look. Many people think that fossilization simply means a creature or an organism that has been turned to stone. Now, that's certainly true for a lot of the trees around here, and that's certainly true for a good number of fossils, but it certainly isn't the case for every fossil. Let's start with this rather wonderful fossil here, similar to the fossils we have here in Scotland. This is actually from the USA though. It's more fossil wood. It is wood that is petrified, and petrified literally means turned to stone. I mean, wood has lots of minerals in it anyway, lots of silica, and in this case the wood has been so silica rich that when it turns into a fossil it's almost turned to glass. You can polish it up and you can see all of the individual rings. This is what we call a cast fossil. Now this in particular is a sea urchin or echonoid, a chynoderm. They're still alive today, and you can see where all the spines would have attached. What's happened here is the little sea creature has got buried in a sediment, in this case it's chalk, and the creature has rotted away and been destroyed, either because of time destroying it or because a chemical process has destroyed it. In this case, just like the bark that we have here on the trees, we have a beautiful cycad. Now what's happened here is the plant has been buried, it's been preserved, but it's gone through a chemical change. So the plant is no longer there, but a different representation of the plant in the form of a chemical change, in this case carbonization. And you've got an imprint of the leaf here. Great fossil. But then there's one final major type of fossil, and it's perhaps one of the most important types. In fact, it's one of the most common types of fossil there is out there. This is a per-mineralised fossil. This is the end of a limb, by the way. Now, a lot of people think that fossilisation means turned to stone, but do you realise that this hasn't actually been turned to stone? The dinosaur bone is still there. So how has it become preserved? Well, minerals from the sediment that it was buried in have permeated the bone. You know that bone is porous, it's full of holes, it's where the blood cells form. It's permeated the bone, it's infilled and entrapped the bone, so it's preserved it. Now, there's another fossil we've got here which is also permineralised. In fact, you've already met him. He is Mr. Fossil Teddy Bear here. Hey, I think he's really, really cool. The minerals have got inside, they've begun to infill it, they've entrapped it. Over a space of about 3 to 4 months, you end up with a permineralised teddy bear, just like the dinosaur bone. 2 examples of permineralised fossils. But they are, in fact, using exactly the same type of fossilisation. And it's a process. You see, this is perhaps the key point. When you're dealing with fossils, you are dealing with a process, and a different process to form a different type of fossil. Fossilisation has got nothing to do with time, but everything to do with a process. Well, that's all the boring fossils out of the way. Let's move on to some of the more exciting stuff. People love dinosaurs. So let's have a look at some of these examples that I've got here in my bag, starting with this rather beautiful tyrannosaurid jaw. Can you see all the sharp teeth? Can you see how they're all sort of cone-shaped? Now, an animal's teeth and the shape of the teeth tells us how that animal ate. Hey, have a look at what I've got here. A great big Tyrannosaurus rex tooth. In fact, this is a cast based off the largest one ever discovered, a whole 30 centimetres long. Yes, this was used for slicing. It was used for cutting through its food. I've got other exciting things in here. Let's talk about something that's, well, it's not quite a dinosaur, but it certainly is a massive prehistoric beast. Oh, it's not this. This is our modern tooth. This is a modern mackerel shark tooth. This is the modern one. And this is the fossil one. Look at the size of it. This is the prehistoric megalodon tooth. So we know from the megalodon shark tooth, it was like a great big great white shark. And then other fossils as well, this time from Spinosaurus. This is a Spinosaurus tooth, one of the largest that I've ever found. It's absolutely beautiful. And again, just like our Tyrannosaurid jaw, no serrated edge. So this dinosaur stabbed his food, unlike the T-Rex, who sliced his food. Fascinating things that you can come and touch and feel from the distant prehistoric past. Now then, our next topic is most unusual, but very, very important for our investigations. Now, all this talk of fossils leads us to a very important question that many paleontologists have. Not all, because not all are happy with shaking the apple cart. But I am, right? We need to actually look at the question of fossilizations. How do these creatures fossilize? Well, the prevailing theory is that there was some major catastrophe, it's like a meteorite or an asteroid or something like that, which caused the dinosaurs to die. And when a dinosaur dies, slowly, over millions of years, these creatures become compressed and slowly turn into fossils, whether it be permineralized or any other kind of fossilization. The key that we've been told over and over again in books and museums is that fossilization is a very slow process, a process that takes millions of years. But is that really what the evidence shows? Now, this is what we call coprolite. What is coprolite? Well, there's no beating around the bush. This is fossil dinosaur poo. Now, fossils like these are very important for paleontologists like me, as well as useful because you can actually cut them up, polish them up and have a look inside, see what the dinosaur was eating. Now, I actually have some cut and polished examples of this coprolite. Here it is right here. This is coprolite dinosaur poo that has been cut open and polished. Now, not only can you tell the kind of stuff that this dinosaur was eating, in this case it was plants, you can also see this little white spot in the middle. In other words, there was a hole there once and it got infilled by calcite, a mineral. Okay, what caused the hole? The answer? A dung beetle! In fact, we sometimes even find dung beetles still buried inside of this coprolite, completely fossilised. This stuff has to be buried very quickly. It has to be fossilised, turned to stone very quickly. This stuff doesn't hang around for very long. It gets destroyed, it rots, it goes stinky and horrible and nasty. You need to bury this quickly. You need to fossilise this quickly. Now, it's obvious in the case of things like coprolite, but the reality is every single fossil on the planet has to be a fast fossil. Slow fossils are no fossils. It simply doesn't work. We've found entire dinosaur skeletons with vomit coming up their throat. We've found entire dinosaur skeletons that have been provably buried from drowning. Buried very, very quickly all over the world. Interesting food for thought. And now for something completely different. Have a look at what I've got in the back of the truck. It's an absolutely fabulous and very unique Draco Rex skull. But what does it actually look like? A dragon, I hear you say? Now, we're just on our way to my little workshop up here, and I'd like you to meet a very special lady called Sue. Let's go meet Sue. Say hi to Sue! The head is based off of one of the largest T-Rex skeletons ever found. Okay, so we've had a look at a lot of different things so far, but we're going to ask ourselves a question now. What does a fossilised teddy bear have to do with a great big dinosaur like Sue? Well, I have another special bit of dinosaur bone down here. This is actually from a giant titanosaur. You know, the one with the big long necks? This is actually from England. And it is also permineralised. Now, what we're about to do is cut Teddy in half. Yes, I know that sounds horrible, but it's important for our research. We're going to cut Teddy in half and have a look at what we see inside. Now, I wonder what would happen if you took a dinosaur bone like this and you cut it in half, just like teddy bear in half. What we're going to see inside is going to be absolutely remarkable and completely unexpected. And in order to find out more, we need to go and talk to some of my dinosaur colleagues in the field of paleontology.
When it comes to places to work, Joe and his wife Sarah Ann exhibit a vast collection of dinosaur fossils and ancient artifacts, situated in a tranquil village setting in Wales. In the interviews that will follow, we will hear about discoveries of blood vessels, flexible ligaments, nerves, skin with colouring, proteins and DNA, published in over 100 scientific papers since 1966, from dinosaur fossils found around the world to marine fossils discovered on the Earth's highest mountains. What you are about to hear and see has taken the world of paleobiology into uncharted territory that may have dramatic consequences in regard to how we understand the world in which we live.
Well, if any of you are a little bit squeamish, I suggest looking away now, because we're about to chop Teddy in half. Alright then, we've got our teddy bear cut in half. We've got our titanosaur backbone. But have a look at the reason why we cut this teddy bear open. The minerals have not quite permeated all the way into the middle. It's still all fluffy, look. Soft, squidgy stuff inside the middle of the teddy bear. The minerals haven't had chance to completely solidify this teddy bear. It's still got soft, squidgy stuff in it, even though it's been preserved using the same process as our dinosaur bone. Now, I wonder what would happen if you took a dinosaur bone like this and you cut it in half, just like we've cut our teddy bear in half. Would you find some soft, squidgy stuff still inside the dinosaur bone? Well, have a look at this footage that you can see on the television behind me. We're going to be talking to the scientist who actually took this footage here and found this soft, squidgy stuff inside of his dinosaur bones. And believe me, what he will tell you will shock you. Soft, squidgy stuff inside dinosaur bones, eh? I told you we'd be making a return to Jurassic Park, but for this section, we really need to pay close attention because we're going to be speaking and interviewing some scientists and researchers who are actually involved in this cutting-edge research, getting their opinion on this topic and what they think the significance of it is. So we really need to pay close attention as we speak to them. Now, I've actually got Professor John Walton here on the line. So, g'day, John. It's great to have you here. Thank you for joining me.
Good to see you. Excellent.
It's been reported that proteins consistent with the presence of DNA have been found in dinosaur remains. Do you believe these reports?
Yes, indeed. The first of these reports that attracted major scientific attention came from Professor Mary Schweitzer. She found soft tissues, proteins, even red blood cells and DNA markers in T-Rex fossils from Montana.
Given all of these reports, what do you think that says about the age normally assigned to these dinosaur remains?
From a chemical perspective, survival of exposed soft tissues or proteins particularly DNA, over millions of years in rocks is simply not credible.
You've written previously about confirmation bias that researchers can sometimes have. Can you explain what that is and give me an example of it?
I find this very interesting. This is the tendency that our brains have, our minds have, to favour and to remember information that affirms our prior beliefs, things that agree with what we already know and cherish.
You mentioned earlier that when Mary Schweitzer first discovered this soft tissue in 1993, that she'd received a lot of hostility from her peers. Do you think it was this confirmation bias which has kept these scientists from accepting this discovery for so long?
Yeah, you're absolutely right there. Yeah. Mark Armitage was a scientist at a university as well. And he published an article showing the soft tissues and the bone cells that he discovered in this dinosaur horn. And another professor in his department walked into his lab, and there was nothing religious in the article whatsoever. It was simply a straightforward report. But somebody walked into his lab, a professor walked into his lab and said, "We're not going to accept your religious prejudices in this university," and he was sacked. He sued the university and got a substantial compensation from them, but that's the attitude, and it's confirmation bias.
So what you're really saying is that as fascinating as this discovery is from a scientific perspective, it goes so much deeper, even to the point of challenging who we are as human beings.
Yeah, very much so. Yes.
Well, thank you, John. I really appreciate you spending time speaking to us today. A fascinating research. Just in case you didn't catch what Professor Walton was saying there, not only is there soft squidgy stuff, but even the reports of living organisms still inside these dinosaur bones, which is just mind-blowing. It's remarkable. And if that wasn't shocking enough, there are those who believe that there's been a concerted effort to try and shut this research down. Now, Professor Walton mentioned one American academic who got into a bit of trouble in actually doing this research. His name was Dr. Mark Armitage. He's a microscopist from the USA, and he's on the cutting edge of this research, in particular looking at Triceratops horns and what you can extract from inside of them. Now, I've actually got Mark here on the line. Let's go speak to him now. G'day, Mark. It's good to see you. It's great to have you here with us. Can you tell me a little bit more about that Triceratops dig that you went on, a bit more about some of the stuff that you kind of found when you started analysing that Triceratops?
We found blood vessels. We found veins. Again, we found nerves. We've also found things called vein valves, which are the little tiny valves inside of the veins, because that's under low pressure. Remember, your arteries have most of the pressure from your heart beating, pushing your blood throughout your system, but it returns through the venous system, right? And that's a little lower pressure. So those valves are there to kind of keep the blood in place in between heartbeats. So it's crazy. And they have tiny little bicuspid valves on them. They're only about a micron thin, which is 1/100th the diameter of one of your hairs. And yet they're still there because I actually made video of this vein valve with bacteria trapped inside. They couldn't get out. They were swimming around, which meant both the bicuspids were still in place, which is astounding. And so we're just kind of following in the footsteps of these paleontologists who've gone before, finding what they have overlooked.
Did you hear what he just said? Nerves and veins with the valves still in them inside a Triceratops horn. I mean, this is just astonishing. Can you try and describe to me how you felt when you were seeing this stuff for the first time? I mean, this is phenomenal stuff.
These cells were so shocking to me that when I first saw them, here's some right here, I just could not believe my eyes. I had to stare at it for about 5 minutes before it became evident to me that I'm actually looking at soft cells. And the reason I know they're soft is because we took other pieces of the same bone and decalcified it and completely liberated those cells. And we squeeze them when they're under the microscope, so we can use cover slip pressure on the glass cover slip to press on the cell, and they wiggle and their little Philopodia, fly around. So these things are so well preserved. It's astonishing because those little Philopodia are only 200 nanometers thin. That's incredibly small. And so for these things to last, like I say, 1,000 years is impossible. But so I was shocked. I couldn't believe it. I really had to take my time and understand what I was looking at. I spent a lot of time looking in the literature, but wow, the feeling I don't think has left me that I experienced when I first saw that.
I mean, this is just remarkable. Life wiggling about underneath the microscope from dinosaur bones. I mean, it's just incredible. You said about how you discovered and observed these nerve cells from the dinosaur remains. Can you tell me more about that? Because that is just, again, it's just remarkable. I mean, these are nerves. This is phenomenal. Tell me a bit more about that work.
Well, it was shocking to me. In fact, these fibers, they're actually fibers. So they can be as long as 200, 300 microns. But then that's the nerve fiber itself. And the way they're constructed, I'll show you a diagram here from the paper. They have this crosshatch pattern on the outside. And there's terminology here for some of these tissues. It's called epineurium and perineurium. And they travel kind of like the DNA double helix around the outside of the nerve. And then inside of those are the fascicles, which are the individual bundles of axons that travel. But no, I mean, you can see in the pictures that we took, first we took a chicken bone and removed chicken nerve from the bone. And I don't know if you can make out the crosshatch pattern in there, but we compared that to the dinosaur nerves we were finding. And look at that beautiful crosshatch pattern there. So now these are showing up over and over and over again. At first, we just called them unknown fiber. And then I started studying the neurology literature and understanding the anatomy of these things. And that crosshatch pattern is a diagnostic feature. So if you observe that crosshatch pattern, you know you're dealing with a nerve. And it prompted us to go back through about 200 or 300 slides that we had previously made, and we found nerve fragments in all of them.
What do you find the most surprising about the survival of this soft tissue, red blood cells and nerves and all this soft tissue?
They can't be there. That's the problem. Cell membranes and things break down so fast, but here we have Philopodia that I've liberated from the bone. They're in solution. I'm squishing them and they're moving around and they're not falling apart. I can't explain that.
What do you think these discoveries say about the age normally assigned to these remains, the deep time remains? Because the stuff that you're finding is remarkable. And like you say, it shouldn't be there.
In fact, I'll say something. This is a world first, so I'm going to give it to you. Treat it well, but I have found nematodes inside of some of these specimens. And so we're trying to work out ways to draw these organisms out of these bones with a media, feeding media that would draw them out. And wouldn't that be a spectacular find? So I think we're onto a good track here, and hopefully we'll bring that out to the scientific community soon.
Nematodes. I mean, just to say, so you know, nematodes are tiny little roundworms. They're quite common, but I mean, nematodes inside it's astonishing. It really is what you're able to find in these dinosaur bones. I feel very privileged to be hearing about that. I mean, that is just, it's mind-blowing really when you think about it, isn't it?
Yeah.
Just phenomenal. Why are people reacting so negatively to it?
I can tell you that the folks who have been vociferous prior to this work are as vociferous as ever. So maybe they feel threatened by the work. I just do an end around and try to reach out to those folks who want to know the truth.
Well, thanks so much, Mark. It's been amazing speaking to you. I mean, it's just remarkable the kind of stuff that Dr. Mark Armitage is finding. It's mind-blowing. And I tell you what, next time I'm in the USA, he's definitely on my calling card. Now, you've probably gathered by now, I'm a geologist. I dig up dead things, but I'm limited by the amount of information that I can get and the kind of data that I'm working with. And I'm also bound by the insistence that the world is millions of years old, even though the science for this really is missing. Professor Neelan, thank you so much for taking time out of your day to come and speak to me about this. As an organic chemist, what do you find surprising about the survival of things like blood cells and soft tissue in dinosaur bones?
Let me give you an analogy. We're walking in the deep woods and we find a cabin and we crack open the door, and it's been abandoned for years. We walk in, there are newspapers from 1945, and we find an old fridge in there. And inside the fridge, we find a milk carton. And it's from 1945. Oh my goodness. We crack open the milk. We expect it to be rancid, putrid. Instead, we pour the milk. We look at it. It looks good. It's absolutely fresh from 1945. Now, would you be surprised at that at all? Well, yeah, I think so, a little bit. Well, in the same way, when you look inside dinosaur bones and you find putative red blood cells and certainly some vessels that carry blood and osteocytes and collagen, and what are these things doing there? It's like finding fresh milk in a 1945 cabin. And so, yeah, there's a lot of surprise there. And that's why these results, when they were first published, were met with vehement displeasure by the scientific community.
It's been reported that proteins consistent with the presence of DNA have been found in dinosaur remains. Do you believe these reports?
I just find it very surprising that proteins would exist for that long. Proteins are meat. And even if I took like a fresh steak and put it in a freezer that I have downstairs at minus 40 degrees Celsius, it's only going to last so long before you can't eat that anymore. And it's not measured in millions of years. It's measured in months, possibly a couple years if you got a really good freezer. So if people are finding proteins mixed in with DNA, and these are even fragments of proteins, what in the world are they doing there? They shouldn't be there. They should have long degraded based on their half-life.
What do you think that says about the age normally assigned to these remains?
These dinosaur bones may not be quite as old as we think that they are.
It is so inspiring to speak to these men who are not afraid to challenge, who aren't afraid to go where the research takes them, even if we don't fully understand or comprehend exactly what it is they're finding. And yet, at the same time, it's disheartening to hear about these prejudices that want to shut down critical thinking and genuine scientific research. And for what? Because it challenges that core belief in millions of years, a belief which is only really based on a philosophy in the first place. Now, my final interview is with Dr. Brian Thomas. He's another biochemist who's done some incredible work in this field, and he's also got some stories to share about how these prejudices really do shut down the research and how they can really hinder it as well. Well, thank you very much for joining me today, Dr. Thomas. I know that you've recently concluded a PhD in molecular biochemistry. Can you tell me a bit about the main findings of your PhD work?
Basically, I was studying proteins, protein remnants that we find in fossils. So we used second harmonic generation imaging, which is a fancy laser light that's connected to a microscope that illuminates collagen fibers. So we can see those inside bone and see them in situation.
How does that research work confirm the findings of what other people had found?
We started to see collagen remnants still inside bones, including Triceratops and other ancient fossil bone material.
Why then is this issue of original biomaterials, or soft tissue as we call it, in dinosaur remains receiving the attention of so many researchers worldwide? What is it that really grips people about this?
It grips some people, but it repels others. It makes the sparks fly, that's for sure. The issue of time, I guess that's the central dilemma. So my colleagues would say you can't negotiate on the age, and so That's why we have such a fierce debate in the academic hallways.
Has the scientific community been able to come up with a coherent explanation as to how these biomolecules and soft tissues can actually persist through deep time?
My answer would be there's not a defensible hypothesis that I've yet seen. It would literally be like asking my cup of coffee to stay hot for a week, something like that, which is why there hasn't been a defensible hypothesis yet.
Can we just get your sort of opinions on some of the biases that scientists have, things like confirmation bias, and a bit of this sort of public perception of science versus what science actually is, or what science is actually supposed to be?
Confirmation bias is a real thing. It's a real phenomenon. And I see it in the literature, and I see it in the labs that I've worked in. The task of a scientist, I mean, we're supposed to force ourselves to be objective, to force ourselves to consider all the options. But that takes character, it takes discipline, it takes work, it takes being open-minded in times and places where you might risk reputation. There's a system in place in the world of science that's got disadvantages to it, and it keeps us, some of us, I think, from being able to see and interpret results in light of perspectives that may come outside the box.
Thank you very much for joining me, Dr. Thomas. It's really enjoyed having a chat with you about these things. You know, there are now so many scientists working on this particular issue, the issue of soft tissue and original biomolecules inside dinosaur bones. It's just an amazing new field of science. So let's hope that this blockade by those who are afraid as to what the evidence will actually lead to remove all of their prejudices and allow honest and open scientific research. Because at the end of the day, if we're truly going to discover the truth about the ancient past, then we need to put aside any and all prejudices and actually follow where the evidence leads. Now, I have an appointment in a field with a little friend of mine who doesn't like to be kept waiting. But the story doesn't stop there. It's been so inspiring speaking to these scientists and people who are on the cutting edge of this research, and now I'm one of them. I'm working with a team of international scientists on a doctorate program in this very topic, soft tissue research, and we're going where nobody has gone before: DNA. Can we extract it? Can we sequence it? Who knows the bounds of this research? But that's all for another day. I still have a friend waiting. Jurassic Park and a dinosaur land will likely remain purely in the imagination of Hollywood filmmakers, and you can see an example of this by the dinosaurs they used. Here we have a velociraptor from the film, a majestic beast, sharp teeth, ferocious, scary. But the reality is, velociraptors in real life were only the size of a big chicken. But then that probably wouldn't have made quite as an exciting film. But let's get serious for a moment, and I want to leave you with this final thought. Given all of this recent research and brand new discoveries, are dinosaurs really as old as we've been led to believe? And if they're not, what does that say about who we are?